Hello everyone, welcome back to another kinetic tutoring episode. Today we're taking a look at FRQ number 4 from the 2024 AP Calc BC exam. So let's get straight into it. The graph of the differentiable function f shown for the interval -6 to 7 has a horizontal tangent as at x is equal to -2 and is linear for 0 to 7. Let R be the region in the second quadrant bounded by the graph of f, the vertical line x is equal to -6, and the x and y axes. Region R has an area of 12. The function g is defined by g of x is equal to the integral from 0 to x of f of t dt. Find the values of g of -6, g of 4, and g of 6. Alright, so let's do the first part of A, where it asks us to find g of -6, where x is -6, so we get 0. The integral from 0 to -6, f of t dt. Now if we take a look at this graph of t, from -6 to 0, we get this area of 12. So if the integral was from -6 to 0 of f of t dt, the answer we would get is the area under the curve, which is 12. But when we know that when we flip these around, you have to flip the sign as well. So we get a negative out in front of here when we flip these around. So this becomes -12. So there's the answer for that first part. We get -12. Now let's try the integral from 0 to 4. That's just going to be the area of the curve right here. And since we're informed that this is a straight line, we notice that this area under the curve is just going to be a triangle. So this f of t dt is just going to be 1/2 base height. So 2 times 4 is going to be 8 times 4 times 1/2 is going to give you 4. Now, if we're evaluating from 0 to 6, it's going to be this triangle minus this little triangle right here. And let's find the area of this triangle. 2 times 1 divided by 2 will give you 1. Minus 1 is equal to 3. So we get -12, 4, and 3 for the three areas. B says, for the function g defined in part A, find all values of x in the interval from 0 to 6 at which the graph of g has a critical point. Alright, so when the graph of g has a critical point, that means that the derivative of g prime of x, is equal to 0. And g prime of x, the derivative of g prime of x is going to be equal to f of x. And this is proven by the fundamental theorem of calculus, because when we have a derivative and an integral, they cancel out, and you use this term times its derivative of x is 0, so it's just times 1. So we want to see when f of x is equal to 0 between 0 and 6, and just taking a look at this graph, it is clear f of x is 0 when x is equal to 4. So there you go, that is the value that you're looking for. Now let's take a look at part C. The function h is defined by h of x is equal to -6, the integral from -6 to x of f prime of t dt. Find the value of h of x, h prime of x, and h double prime of x. Alright, so using the fundamental theorem of calculus, once again, we can find that h of x is going to be equal to f of x. So if we're evaluating it from -6 to 6, then we just get f of 6 minus f of -6. F of 6, looking at the graph, is -1 minus f of -6, which is 0.5, gets you -1.5. H prime of x will give you f prime of x. F prime of 6, this is a linear line, so we find the slope of the line. It goes down 2 and it goes over 4. So -2 over 4 will give you -1/2. There is your slope. So h prime of x will be negative 1/2. So let me just write all of these out. H of x equals negative 3/2. H prime of x equals negative 1/2. And then we want the second derivative of 6. This is just a straight line, and we know that the derivative of a straight line, since it's neither concave up or concave down, is just going to be 0. So the second derivative, therefore, of h is 0. And I meant to put 6 for these values of x. H of 6, h prime of 6, and h double prime of 6. So there you have it, guys. That's how you go about solving all three parts of this problem. If you have any comments, questions, concerns, make sure to leave them down in the comment section below. If you enjoy this video, make sure to leave a like and subscribe, and I will see you guys next time.